And so for the folks who have that, what I call the tinkerer gene, you just have this amazing ability to scale it up or scale it down so that you can have it do exactly what you want it to do and nothing else.
We've likely all asked the question at some point, what is so great about Linux? Why do cybersecurity professionals, programmers, and most IT professionals use Linux so much? I know I asked when I first started learning Linux, but the more you dig into the platform, the quicker you realize the world runs on Linux. And that's no over-exaggeration. Your TV, your smart appliances such as your fridge or even toaster, heck, there's probably a 50-50 chance the phone in your hand right now runs on Linux. So to figure out why Linux is so popular and how you can leverage it in your career, I've actually brought on Clyde from the Linux Foundation to talk about this very topic. So without any further ado, let's roll into today's episode. Welcome to the show. Can you tell us a little bit about your role at the Linux Foundation and your journey into the world of Linux?
Thanks, Dakota. I appreciate the opportunity to be here with you and with your audience. I run the group at the Linux Foundation that does training and certification, which is interesting because when I started 10 years ago, if you talked to people about taking formalized training for open source software, they would kind of look at you like maybe you were that 90-pound weakling that couldn't figure out from reading the docs and the README files. But of course, as the usage has grown, people recognize that software is software, right? It doesn't matter if it's coming from a big corporation or not. Nobody ever learned Oracle by figuring it out on their own. And so the key is, do you have a source for neutral education on the material? Because often what happens, of course, if you look, for instance, at the entire public cloud, right, is running on Linux and Kubernetes, and they take those programs and they wrap it into a proprietary offering. And so any training that you get would be specific to their version. When you're just starting out, you just need to know the basics, right? And so that's what we provide is entry-level gateway into what is Linux, what is Kubernetes, why should I care, how is it going to affect my day-to-day life? And it was interesting because when I started, I was a complete open source newbie. So the first thing I did was take my ThinkPad and strip it down and put, at the time, Mint on it. And I figured, well, the only way out is through. So let's just, start using it. And I still run, the machine I'm on today is still a Linux machine because I figure that's the way to really get up against the coal face is to just get in there and be among the many trying to figure it out. It gives you more empathy for the folks who are just starting their journey.
I think that's really very similar how I got my start with Linux. When I decided to get into the tech industry, I knew Linux was a vital tool that I needed to be familiar with. And I'm very much of the mindset trial by fire. And, I ended up dual booting originally my PC with Linux. And at the time, Ubuntu was, very popular and stuff. So I just went in with the basic Ubuntu desktop and uh I crawled for a long time and before I learned actually how to get in there more. But I really want to kind of dive into the Linux Foundation really quick. And just for those who are not familiar with the Linux Foundation, can you give me a little bit of backstory about like just a little bit deeper dive on what you guys do over there?
Yeah, it's interesting because quite often when I'm in discussions with folks and they hear the Linux Foundation, they maybe have an idea of what Linux is, that it's this sort of hobbyist OS that sort of true geeks use. And so when I tell them that, they've probably used Linux 20 times today because their Android phone, their fridge, their car, everything with a microprocessor in it, they sort of get this look in their eye like, that's not actually what I thought. The other challenge is, Linux is, although we love it, is now one of about 800 different open source projects that the foundation manages. So sometimes I think maybe we need another name because, everything from Kubernetes to a bunch of distributed ledger stuff. And so, the key role that the foundation plays, we're a nonprofit organization, is to provide a neutral home for governance so that we can encourage shared collaboration, right? And so one of the lines we've been leading with in terms of describing who we are is shared collaboration based on trust. And so how do we create an environment where people are willing to bring their passion and contribute code, review code, advance the cause of whatever it is they care about, working collaboratively with others, some of whom they've never met, many of whom they might never meet. And unlocking that potential for shared collaboration is really what we're all about, right? And how do we do that in a way that gets developers excited? How do we do that in a way that gets users and companies excited about building dependencies into these projects, into the products they use every day?
Yeah, absolutely. And let's kind of unpack that a little bit more. Why do like so many companies run Linux and rely on it so heavily?
If you look at the history of computing, it started off as very DIY and people sort of building their own machines. And then you got into that early era with Big Blue. And for the next maybe 30 years, people loved to complain about lock in with their provider. And so, there was this long history of, you might describe as a love hate relationship with the providers, the dominant commercial providers of software. And then at some point in the probably early to mid 2000s, more of these projects, starting with Linux, but also if for the folks who are old enough to remember the LAMP stack that powered the initial wave of the web, which was Linux, Apache, MySQL, PHP. The idea that you could use open source projects that you then had ability to access the code so that you could tailor it to do exactly what you wanted to do without it having to be a six-figure professional services consulting agreement with your provider, and that you could improve it if you wanted to, and that other people could improve it and you could get access to their improvements. I think it sort of set off a light for folks that, particularly when you're thinking about the what I call the sort of infrastructural layer of systems, so the OS, the networking, the storage, that you are better off relying on things that are collaboratively built and openly available, because you can still build a commercial product with it, but you're not caught between what used to be the choices of you had to build everything and maintain everything yourself in-house in your super duper secret basement lab, or you had to take off all these dependencies on partners who might sometimes go in directions that you wouldn't have wanted, or maybe the price keeps going up. And so the idea of open source collaboratively developed software at the sort of infrastructural layer, I think, started to take hold. My own hypothesis is the LAMP stack was kind of the genesis of people thinking, this is more than just hobbyist software. This is real software that I could run on. And of course, the real, if that was the fuse, the stick of dynamite was the public cloud, right? And so when you look across the world, 100% of the public clouds are Linux as the OS, Kubernetes as the orchestration layer, and then a variety of other tools like Prometheus and FluentD sort of baked in. That hasn't stopped, pick your provider from having a commercial brand around their product and having ultra high reliability and scalability, right? And I think that growth of the cloud, for the folks who weren't maybe so close in, that was the tipping point at which they realized, this collaboratively developed software is actually great. It's faster, it's easier, it's cheaper, it's more secure, it's easier for I can modify it to do what I want it to do. And then you started seeing this explosion, right? So most of the 5G networking stack, the previous generations were very hardware driven, right? Switches and routers and things programmed. But when you moved to 5G and you had 10, 20, 50 times the number of points of presence, you had to move to a software layer to manage that network. And collaboratively, the providers decided, the best way to do that is to jointly work on a series of things for the data plane, for the network function virtualization, that we can all rely on. And that's what you see today rolling out, right? The 5G infrastructure. Again, globally, if you look under the hood, there's a series of interlocking, collaboratively developed projects that run it. And the list goes on. Financial services. I think it's in the water now, and I think people are realizing that life's better when you collaborate at the core functional layers, because you get the best of both worlds. You still get to build your product, and you get to have a lot more flexibility, visibility, and better economics when you do it together.
Such a great example. And obviously Linux is here to stay and is arguably becoming more popular, more mainstream now. And I want to dive into some career advice. What advice would you give someone who's looking to start off their career in the IT world and they're really wanting to kind of specialize in Linux? Just some general advice you have.
Well, what I tell people is, if you try to forecast the future, which is dangerous. It's difficult to envision the next 5 to 10 years with computing being anything other than largely cloud powered. And all the stuff that's going to add on top of that in terms of extending with Internet of Things and 3D rendering and artificial intelligence. And if you start with that premise, the gateway into that world is ask the question, what is the operating system going to be? And the answer, of course, is that Linux powers the cloud. And if you ask yourself, well, okay, what's the next layer of technology that's running that? It's containers. And what is the orchestration layer going to be? It's Kubernetes. It's like learning the alphabet, right? You're going to this foreign land. The first thing you want to do is learn the language. The first thing you should start doing is, what's the alphabet? What's the basic grammar structure? And that's how I think about Linux and Kubernetes, as well as the associated things, right? Like understanding, what is GitHub and why are people always going on about it? And what is a pipeline? And I don't really understand what that means. And so the advice I always give folks is start with the basics, understand how software gets built, and understand what software gets used. And if you go down that path, what you find yourself doing is you realize you need to learn at least the basic commands in Linux, because regardless of your cloud provider, you're going to drop down eventually to a command line and you're going to run, pick your, curl or top or whatever, just even as you're a newbie getting started. So you need to know what that is. You need to know about collaborative development and things like GitHub. You need to understand things like pipelines and DevOps, and then you need to understand containers and Kubernetes. And armed with that, that's sort of like your, for those of us who are old enough to have traveled with like little phrase books, that's your phrase book, right? It gets you into the foreign land and sort of basically functional. And then from there, you have to take the initiative and figure out where exactly you want to be in that ecosystem, right? Are you a data person? Are you a front-end person? Are you an app developer? But that's what you need to get started. And it's become pretty homogenous if you think about sort of cloud computing and the platform it provides for folks. And so that's the advice I give folks is go build your phrase book. These are the component pieces of it.
In the IT industry, I'd like to hear your opinion, the balance between skills and experience and formal education. Where should people be focusing?
When I speak to hiring managers, what I hear consistently is they care about what you can do. They want to give you a problem to solve and see how you solve it. And the formal training piece may help with the upfront evaluation of candidates as people are applying and just kind of sifting through the pile. But ultimately what they're going to hire on is skills. And there's so many examples, and every hiring manager will tell you stories of the folks with unconventional backgrounds who are killing it on their team. And so that idea that there is no prerequisite that you must have in order to be functional, I think is very real. And you see that increasingly with large companies taking formal education requirements off the table. I think having said that, one of the things that we think is really important, because so much of open source software as it comes out is new and innovative, even if you look at things like Kubernetes, it hasn't yet been 10 years,
That's
right?
crazy.
That has been an open source project and come to dominate. If you go in the not so way back machine, you remember Mesos and Docker Swarm, and there were these other ways to maybe potentially orchestrate. So there is nobody other than folks at Google who has a decade of experience, right? And so as technology keeps rolling out, you have new and unfamiliar. And so everybody wants to hire somebody with 3 years of experience. Well, good luck with that, right?
Yeah, absolutely.
What we have focused on is training that is very labs front and center, and exams that are live system tasks front and center. And quite often the number one complaint I get from folks about our training material is it's not entertaining. Like there's no videos and things flying off and confetti raining down. And I think, well, yeah, because I'm not actually trying to entertain you. I'm trying to get you to the lab so that you can actually work on your skills.
Because that's really important.
Learn a few things, try it out. Learn a few more things, try it out. build those skills, right? So chapter 3 is reinforcing skills from chapter 1. You have to eat your veggies, right? The only way you build skills is by practicing skills. And so that's very much been our mantra is practice, practice, practice. Have the curiosity to go figure out some stuff on your own. Like everything will not be pre-digested for you. I don't care how extensive your training is. There's always going to be that one package that you need to go get, or that one service which you didn't fully understand, or a rate limit hiding somewhere deep in the bowels of the system, right? You have to have the tolerance for some ambiguity to be able to know that there are going to be times where you're going to need to figure it out on your own, and here are the ways in which you do that.
I think it's something that needs to be said because this doesn't just apply to like the Linux world. This applies to really everything in tech you could go to learn, whether it's the cloud, whether it's networking. Anyone can read on how something that works, but until you actually get in there and get your hands dirty with, you know, the different processes and controls, not all documentation is great and or 100% accurate. You'll learn things by actually like getting in there, and you'll find easier ways that things work. And it's the best way in my mind. I'm a hands-on learner, and I love to figure out how something works, and then I go try to break it. You know, and that's how I learn, and that's really how you can cement, you know, great knowledge.
I think one of the reasons why, from a practitioner perspective, open source software has become so widely used, because you can drop to the code, right, the uncompiled code, and start figuring out, hey, I really wanted it to be able to do this thing, or I really wanted it to not do this other thing. And you have a level of superpower control that you wouldn't have in traditionally sort of packaged, precompiled software. And so for the folks who have that, you know, what I call the tinkerer gene, it is amazing to get in there and find that you can, you know, you can take a Linux kernel and strip it down so that all it does is tell you whether this window that I'm looking out through here is open or not, right? That's all it does, is one function. Or you can have it, you know, power that last NASA rover that went to Mars, right? So you just have this amazing ability to scale it up or scale it down so that you can have it do exactly what you want it to do and nothing else, if that's what your aim is.
You're 100% correct there. So I'm going to ask the most burning question, and the question I think I hate the most: degree versus certification. You know, what is your opinion versus, you know, this traditional university degree versus like professional certifications in the IT industry?
It is a fraught question and people get really hot and sweaty, but the thing I always go back to is every person is different. And so there are a lot of people who benefit from a university degree education because it's more than just what's on the curriculum, right? It's the fact that you have to do group projects. It's the fact that you're away from home and having to be independent for the first time and do some of your own research projects. And I think for some people that might light that gene of self-sufficiency. But it's not for everyone, right? You know, I've got folks on my team who didn't have comp sci backgrounds, who are amazing technologists because they have that tinkerer gene. And when it comes to certification, we are kind of in the true believer category that certifications matter if you've demonstrated skills. And so the picking an answer out of a lineup, the internet blew that up 15 years ago, right? I mean, every exam that comes out that is multiple choice, 6 hours later, the entire bank is online. So if you want to cheat, you can cheat, and there's no way, you know, by preloading up on what the content is, and you're going to get a great score. Now, you are going to get unmasked during the interview pretty quickly once people realize it.
Yeah.
You know, and that's one of the things that we focus a lot in our certification exams on performance-based, because the number one frustration you get, especially in the LinkedIn era, is hiring managers saying, oh my gosh, I brought this person in, I set aside an hour, and 6 minutes in, I'm just thinking, how quickly can I extricate myself from this interview? With this person,
Yeah.
you know, nothing they claimed on their social profile is actually accurate. And so that's the piece where we think we can help, right? Is if we validated somebody has the skills, we've actually had them do the skills in a time pressured, under observation manner. That's a pretty good proxy for, are you able to do it? And by the way, when the way we develop our exams, you have access to the web. So if you need to go to a wiki to look something up or a resource page, you can do it because you know what? In the real world, that is exactly what you do,
That's so awesome.
right? You go to the wiki, you go to Slack Overflow or somewhere, and you ask for help. And so we try to provide a realistic experience within which to demonstrate the skills you have, because we don't expect people to have 100% skills coverage. We expect them to have broad skills coverage plus the ability to go figure out the bits that they're not intimately familiar with.
That's really relevant to how it works in the real world. No person in tech knows it all. At least most of them, most of us don't. Going to documentation, online documentation, checking online forums is really a daily or a weekly part of the job. And, you know, some people really frown upon that, I think, in the industry, or worry that that's not acceptable. But in my opinion, if you're not having to constantly go and learn new things, you're not advancing in your career. You're not advancing your skill set. If you're just staying in your like comfortable bubble, you're not growing in your career. So challenging yourself to do those things that you're not familiar with, and understanding it's okay to, that if you don't know it, there's resources out there. You're not reinventing the wheel. Someone has likely already done it, especially when you get into like the open source world of like Linux and stuff like that.
This is why staging servers were invented, right? Have a safe place to practice.
Absolutely. And before we move on from this topic, I'm curious on your opinion on some of the pros and cons versus on the degree versus certification talk.
I talk a little bit about some of the potential benefits of somebody going through a degree program. Um, I think it also helps some people. Some people are much significantly more mature at 21 or 22 than they are at 17 or 18. The challenge, from my perspective on computer science education, is, and I've spoken to many computer science deans about this. In order to stay accredited, there is a list of things they have to cover, which bears very little resemblance to the list of things you would work on day one of a job. And so they're caught in this impossible bind of it takes them 4 years to cover the things they need to cover to stay accredited. And I've had more than one dean of computer science tell me nobody wants a 5-year degree, so we do what we need to do to stay accredited because it's not valuable to people if their program is not. And we encourage them to go figure out all this open source cloud stuff kind of on the side. And that to me is the real downside, is the accreditation process for universities has not kept up with the speed at which computing has developed. And I think in many cases, if you speak to folks who hire directly out of universities, there is, I wouldn't even say a latent frustration. I would say it's a pretty obvious frustration about the skill sets that folks come out with. And are they familiar with all the things we were just talking about, containers and pipelines and Git and flexible, truly agile development methodologies? And far too often the answer is no, which means that they either had to be a tinkerer and have figured that out kind of on their own, or you have to put them into basically an apprenticeship program and kind of boot them up. So I think that's kind of the downside, is within our model, it's difficult to provide the coverage of the skills that every employer will tell you is what they're looking for at somebody, particularly at the entry level. I think on the certification side, there's two challenges, right? One is the skills challenge we talked about, right? It's like, did you actually make them demonstrate practical hands-on skills? Because at the end of the day, that is what companies are hiring for, right? They want you in the team doing a particular role. I think the other limitation is any certification exam. We always talk about this with our development team. A certification is a sample of competencies, right? And so you go through this process and you work with industry experts to say, okay, what are the skills, the minimum set of skills that you would want to know that a person has? But you can't cover everything, right? And because nobody will ever take a 12-hour exam, right?
Yeah.
Most exams, you look out there in the wild and they're, for the most part, somewhere between 2 and 3 hours, right? And so there's always this limitation on what you can, on the competencies you can sample and still have it be a reasonable experience for the user. And so even if you're certified, it doesn't mean you're good at everything, right? And so it's not a hall pass to a hiring manager to say, I'm going to close my eyes because this person is certified. And networking may not be the bit that they're strong at, right? Data table processing might not be the thing they're strong at, right? Security might not be the thing they're strong at. So you still need to do your due diligence, right? It is not a magic wand that suddenly makes this person, a sort of, a universal connector that you can just drop everywhere because of the nature of trying to do an exam that's a couple hours long. And that's one of the contrasts with, if you had a great degree program and somebody had spent 3 or 4 years, you get a lot of coverage, right? You could expect a lot of broad coverage. And so there is no magic bullet, right? You have to evaluate people comprehensively. I happen to think that the more proof points you have that somebody can work independently, do the tasks independently, problem solve, particularly under time pressure, that's really what you're looking for as the core capabilities that's going to make someone a good technologist.
So I actually understand that the Linux Foundation has this IT professional program. Do you mind telling us about this and what opportunities for individuals looking to start off and advance their careers in the IT industry?
We put that program together basically in response to the line of thinking that you and I were just talking about, Dakota, which is there's this kind of constellation of things that for people who are familiar, it is, they would kind of roll their eyes and say, well, of course you need to know pipelines, of course you need to know Git, of course you need to know Linux, of course you need to know containers. If you are on the outside looking in, and particularly for people who are coming from communities where they don't have role models of people who've been in tech, right? They didn't grow up with parents and uncles and neighbors. Somebody has to help them kind of get their arms around what does it take to be competent in terms of the different mix of skills. And that's kind of what we try to put together and it's not a short program, right? So I see a lot of stuff on the internet about boot camps, 12 weeks to be a coder. I can't even train my puppy in 12 weeks, but sure.
So true.
What we try to set the expectation for folks is, look, if you work at this full time, like you would a job, it probably takes you anywhere from 9 to 12 months because there's a lot to learn. And so when we talk about this IT program, we deliberately don't call it a boot camp because I think boot camp has some connotations that of speed and
Yeah.
hey, 3 months from now you're a developer, and you and I both know that breadth of skills that you need is not something you can do in 3 months. And so we put this program together to basically say, okay, what is the minimum set of things that we think somebody has to know? Now, it's the minimum set of things, right? It doesn't guarantee that you're a perfect fit for every job there, but I think for most employers, if you go up to them and you understand those key principles and you can demonstrate that you have actual hands-on practical skills being able to do it, that you will find a pretty receptive audience there, right? Folks understanding that you're at sort of the career entry level. But it's also true, as we rolled out the program, we realized, there's actually a second audience. We designed it initially thinking about that person coming out of high school, or, maybe they went and they worked in the service industry for a couple of years and they're like, oh man, okay, need something a little bit with better prospects than this. But it also turns out there are a large number of folks who've only ever worked in highly proprietary, waterfall driven, in-house type systems. And in fact, we're however many years you want to call it into the cloud revolution, right? 5, 10. There's a lot of computing that still happens on legacy platforms. And there are a lot of people who still, their day job is to maintain those legacy platforms, but they can't run them forever. I think, when Solaris went off market unsupported several years ago, that was a great example of the fact that eventually the music stops and either there's a chair for you or not. All those folks, they can reskill and upskill into this new way of working on those same sets of things, right? Git and DevOps and Linux and containers. And so when we say it's an IT professional program for cloud, yes, there's a primary audience of folks who are new coming into tech, but there's also an audience for folks who have worked in a very different way of building tech, and maybe for 10 years, maybe for 15 years, but they need a bridge to get them into the agile cloud container driven way of computing. And this is a great way to do that, right? They don't need to step off and go do a 3-year degree or a 2-year diploma. They can do this while they work, right? They can build these skills iteratively. And the fallacy that I always talk with employers about is everybody wants to hire somebody today that is the best person they've ever seen on XYZ, right? That's what we all want when we hire. So you talk to them about upskilling an existing person, and the reaction is, aha, it's going to take 9 months, and then at the end, maybe they just leave and go somewhere else.
Right.
Well, not everybody leaves, and frankly, the cost of upskilling somebody is vastly lower than the cost of hiring somebody. But even beyond that, when you start pressing in and you ask hiring managers, from the day you post that listing for this mythical perfect candidate to the day that person starts, how long does that take? You know what you hear pretty consistently? 6 months, 9 months, 10 months, 11 months.
And also, what happens if that person you hire ends up leaving or not working out? You're back to square zero. Yeah.
Even after they've started, it's another 3 or 4 or 5 months before they get into the flow of your tooling and your culture and your stack. And so there's no universe where you've got a productive person in less than 10 to 12 months anyway. So why not upskill the person who you know, who's been part of your team, who is reliable? And you know what? If, even if half the people you upskill leave, you're still better off, right? Because the cost of upskilling is, in the hundreds, maybe $1,000 range. The cost of hiring with a headhunter is 20, 30 grand. And the risk, right? The point you made of like, okay, this person interviewed great, but 2 weeks in, I'm thinking, I used to work with a company at one point, and they had this acronym for people who didn't work out, and it was PURE, and PURE was a previously undetected recruiting error.
Yeah.
It's and not or, which is the message that we try to take to folks. Is look, hiring is great, but it can't be your only strategy. You've got to work on building. Talent is something you build, not just buy.
That is so true. So as we land the plane here, I have one of my most favorite questions to ask. Do you have a scenario where something went like catastrophically wrong for you in like the Linux world? And can you tell us like how you're able to leverage some of the tools within Linux to save the day?
We had a example where we were doing a major update to a piece of the development ecosystem, and the primary developer who was working on it built a service, tested it out, and in staging, and it didn't work. He thought, you know what, rather than tinker with it, I'm just going to delete that service and I'm going to rebuild using a different methodology. Well, it turns out that many years prior, when we had built that part of the service architecture, the permission controls on the database access were not set correctly. And so when this person deleted this module, there was a hook into the database module, and there was no proper control on read-write access and governance, and they ended up deleting the production database. We then subsequently looked at it, and there was actually 2 other places that had unprotected access. But nobody knew, right? It was just one of these things where it wasn't a reasonable thing to have happened, but all of a sudden the tickets start flowing in, and it takes the team a while to figure out how can this be, because the only way we could get all these errors is if the whole production database was missing. Oops.
It is missing. It's not there.
And this is this whole idea of flexibility, right? The team was scrambling around trying to figure out how do we're a training company. People are taking courses and exams every single day, like 24/7. It's a global operation. And they were able to find a cached database backup service that was sort of really kind of off the beaten track. It was something that was provided to hook into the larger LF data lake project. And it just so happened that that service had taken a snapshot like a few hours before.
Oh, wow.
And they were able to go find that snapshot, re-import it in, reinstantiate the database, and get it up and running with pretty minimal, we lost a couple hours of data. But that was not in the manual, right? This was just an understanding of, okay, where all could this data potentially live? Because this is pretty catastrophic. Customers are calling, and we could go do the whole S3 bucket backup and try to recover, but that was, this is every whatever it was, 36 hours, and so now you've got a day and a half of data loss. And they were able to go just think creatively through where all might we have had sort of mirrors of that data, and then sort of re-import it back in to save the day. I think a great use case of how when you have these flexible distributed type systems, when disaster strikes, the creative juices start flowing to think about, okay, what's how might we sort of restore back to where we need to be. And there's more, that was probably the highest drama version of there's small versions of that happen every day, right, for everybody
Right.
who runs the live system.
No, that's an awesome story, and it's the reason I like that so much is it gives people kind of a glimpse into, everything's not always perfect. Things go wrong, and it's a great learning opportunity. It's a unique learning opportunity, and you find out skills you didn't have before, and while they suck during the instance, while they're happening, you can really learn a lot from those. And we're all human. We all make mistakes.
In big complex systems, no matter how much you try, there are weak points sort of hidden away somewhere.
So true. So if people want to find out more about the Linux Foundation or possibly want to connect with you, where can they go find some more information?
So, linuxfoundation.org, training.linuxfoundation.org, right, to see what we have. There's a large breadth of both free and paid material that we try to put out there. Find me on LinkedIn, so Clyde, like Bonnie and Clyde, C%. There's only one of me, as far as I can tell, on LinkedIn, so pretty easy to find. But love having these conversations, right? And just trying to talk with folks about the way in which computing has changed, the importance that open source has taken as a core part of pretty much any ecosystem that you can think about, and what are the pathways for getting involved. I think to me that's the big thing. We look across, and the one thing you hear consistently, I don't care what industry you're in, I don't care what geography you're in, everybody is wanting to bring more talent in because they're expanding their use of computing. And it's really interesting to see all these industries that used to be retail and places that used to be very much sort of technology agnostic, reaching for how can I, seeing that there's a pathway to use these technologies to improve their customers' experience, improve their ability to operate efficiently. And so in that mold, we need more people. We need more good people in. We need to bring more people into the opportunities that a tech career can provide from sort of outside the typical supply chain of people. And so that's what gets us excited. Can we get more people in? Can we get them promising careers? And can we also then address the need that we hear from all the folks who are running these systems that says they need better talent?
Absolutely. So much great advice. And I thank you again for so much for taking the time to join us this morning and, share some of your wonderful knowledge.
Thanks so much for having me, Dakota.
Absolutely. Well, I hope you guys enjoyed this video. And until next time, keep learning.